Let's understand the reinforcement or rebar lapping zone to RCC beams. If the span of a structural member needs to be increased beyond the standard length, 12 meters, of the reinforcement bar, then we must increase the length of bars by adding extra steel bars. The most important thing, we can't add the bars directly from end to end to avoid the risk of steel sliding out of concrete. That's why we overlap the bars at certain points to allow a smooth transfer of loads from one bar to the next. In this video, I'm going to discuss what should be the position of the lap in the case of beams. That is to say, a lapping zone in beams. Before deciding the lapping zone of beams, we need to identify the points where a member is subjected to a maximum bending moment, or simply, we need to identify the tension zones of a beam. For illustration, let's consider a continuous beam that is subjected to a uniformly distributed load. Due to this loading, the beam will tend to bend in a way that the maximum bending moments will be generated at the center of the spans. There will be positive moments at the center of the spans and negative moments at each support. Due to the maximum bending moment, the top fiber of the beam at each end and the bottom fiber in the mid-span will experience maximum tension. Hence, they can be called tension zones of the beam, and we can't overlap the bars in tension zones, because the reinforcement bars would come out of the concrete due to maximum stress. For bottom bars, we can't overlap the bars at the mid-span of the beam due to maximum tension in the bottom fiber of the beam. On the other hand, the top bars can be overlapped in the mid-span of the beam due to minimum tension in the top fiber of the mid-span. If we divide the span into 3 equal parts, the overlapping of top bars should be done in the intermediate zones, and each bar should be overlapped at alternative levels within the lapping zones. The bottom bars should be overlapped at column junctions up to a distance of L/4 from each end, and each bar should be overlapped at alternative levels within the lapping zones. Note, not more than 50% of the bottom bars in a beam are overlapped in the same zone plus columns of any clear span. Now let's understand the lapping zone of reinforcement bars for a column. Now, let us go through 7 basic rules while lapping the rebars in columns. 1. Lap length diameter. When we extend the top bar of the column from the bottom bar, having an unequal diameter, then the lap length is calculated for the smaller diameter bar. For example, if the upper bar of 16 mm diameter is lapped with a lower bar of 20 mm diameter, and if the lap length is taken as 50D, then lap length 50D equals 50 times 16 mm equals 800 mm. Correct lap length 50D equals 50 times 20 mm equals 1000 mm incorrect. But then remember, 50D is the minimum lap, therefore from our illustration 50D is equal to 800 mm, which is the minimum. It means the lap shall not be less than 800 mm. 2. Lapping zone. When we provide lapping in a column, all the rebars should be lapped in zone as shown in the drawing. The top and bottom portion of the column, I.E.zone-A L/4 length, should be avoided, as there will be a maximum moment in this zone due to lateral forces acting on the column. If the length of the column is L, then the L/4 length from the top and bottom of the column is categorized as tension zone, and the center L/2 length of the column, zone B, is considered a safe area for the lapping purpose. 3. Staggered bar. All the bars that are lapped should be staggered within zone B as shown in the above drawing. In any case, not more than 50% of rebars should be lapped in the same level. If all the column bars are lapped at the same level, it leads to the failure of the column. 4. Stirrup spacing. The spacing of the stirrups in the lapping zone should be minimum when compared to the regular column C/C stirrup spacing. If the designed regular spacing for the column stirrup is 175 C/C, then the spacing of stirrups in the lapping zone may be 150 C/C or 125 C/C as according to the column design. 5. Welding the rebar. As per PS code, if the bar diameter is greater than or equal to 36 mm, then you should consider welding those bars instead of lapping. If welding is not possible, then you can lap these bars with an additional spiral of 6 mm bar at the splice length. 6. Joggle length. For the rebars of diameter greater than 12 mm, you can consider providing a joggle of 1 and 6. That means if the bar is 20 millimeters, then the length of the joggled part of the bar can be calculated as equals 6 times diameter of rebar equals 6 times 20 millimeters equals 120 millimeters. 7. Rebar placing. When we tie the rebars in the lapping zone, the joggled part of the bar should be placed over the inner surface of the bottom bar as shown in the above drawing to get a uniform clear cover from the concrete surface. If you tie the joggled portion of the rebar over the outer surface of the bottom bar, then the lapping zone invades the concrete cover area provided for the bars. Hope my viewers you have understood the lapping zone and beam and the guidelines of lapping in column as well.